All right, this is a video lecture beginning with Chapter 5, States of Consciousness. All right, so as always, usually in class we start off with our Mythbusters, and I think I'm going to just skip this. I'd rather do this on Monday, and by then you would have started reading the chapter, so you'll probably know the answers to this already, but I'll move on. So let's get started by talking about consciousness, sleep, and dreaming. When we're defining consciousness, other than when we're awake, two or more common states of consciousness would be sleep as well as dreaming. Think of it as yourself as being unconscious while you're asleep, but you know what? That's really not true. Instead, you're kind of in an altered state of consciousness. When we're talking about within this chapter, we're going to look at how we learn about these states of consciousness and why we spend so much time in it. Okay, so make sure you know the definitions. Consciousness is considered to be an organism's awareness of its own self as well as its surroundings. And then altered states of consciousness, ASC, is going to be those mental states that you're found during sleep, during dreaming, in terms of psychoactive drug use, hypnosis, and so on. So there are different levels of awareness when we're talking about our states of consciousness, okay? You're basically think of it as a streaming of consciousness. It can vary within its depth. Consciousness is not just an all or nothing type of phenomenon, pretty much like or conscious or unconscious. Instead, it goes along a continuum, okay? It's where if you're at low level of awareness, you can consider yourself at that point of you might be sleeping, you may be dreaming, you could be under anesthesia during surgery, or you can even be in a coma. Mental awareness is during those times where our automatic processing is going on. That being when you're walking, you're doing that automatically. You really don't think about it. Particularly like if you're in the middle of another task like walking, you're automatically holding that phone and you're talking and you're still walking without even having to think about it. That's what we call mental awareness. Higher level awareness, which I hope everybody is, the example on the slide shows about driving a car. Well, here, that's when you're utilizing all tools and you're paying attention to the road. And this all requires keeping attention, being focused. Although driving feels like an automatic response, many times we still have to pay attention to the rules of the road. That being, you should be looking all ways at all times, checking your mirrors, and watching for those that's in front of you. Now, how do our body goes in terms of different levels of consciousness? Also, it goes into saying we have to look at our circadian rhythms, our alertness, our body temperature, our moods, how we learn, how well we learn, our blood pressure, your metabolism, the pulse rate. All of this is actually regulated through our circadian rhythms. Now, usually when we're talking about these type of activities, we're thinking about how they reach their peak and it goes on throughout the day at its high point for those who are awake during the day, and then low point when you're asleep, it comes down. Now, that doesn't all necessarily mean that everybody has the same circadian rhythms. Everybody goes a little differently. But understand, when there are disruptions within our circadian rhythms, it causes increased fatigue. You can't concentrate as well. This is when sleep disorders may occur, as well as having other health issues. Because guess what? You're going to get stressed. And we just finished the chapter on stress, didn't we? So one thing I want you to make sure you jot down and remember that circadian rhythms is on a 24-hour clock, basically. Okay, our body is accustomed to working off of that time period. All right. So when we're talking about our circadian rhythms and we're talking about sleep, think about shift work. Any of you actually have a job like working in fast food restaurants or other type of restaurants, excuse me, um, or do you work in a hospital in which you may encounter shift work? Many physicians, nurses, law enforcement officers, or others, they work off of a rotating schedule. Approximately 20% of employees in the United States alone works on a shift schedule. And for the most part, we're able to manage and function well. But studies have been able to demonstrate that shift work as well as sleep deprivation can and probably will lead to decreased concentration and productivity. And those with dealing with shift work and dealing with sleep deprivation, the likelihood of accidents occurring increases. So one thing research has been able to suggest that if shifting from days to evenings to nights, it kind of makes it easier to be able to adjust to dealing with rotating shift schedules. And that's because it's easier to go to bed later than the reverse. So productivity and safety, it can also increase when shifts are rotated every 3 weeks rather than every week. So if you have an employer who tries to put you on a early morning shift and jump you straight into mid shift, it'd be good if they can reverse that, so to speak. So if you started off on an 8 to 4, it would be okay to allow you to move to a 4 to 12 and then to a 12 to 8, for example. Now let's talk about sleep. How many of y'all get a decent number of sleep? I can't raise my hand on that. But let's talk more about it and see what's going on with us. So there's consequences when there are impairments from sleep deprivation that ranges from threatening your school performance to endangering your physical health. But the most frightening type of danger that can happen is the lapse of attention when you're doing things that's important and can be within life or death situations. Think about doctors. Doctors work very long shifts, for example. Some of them could be working between uh, 12 to 24 to some have even done 48-hour shifts. Think about truck drivers when they're on the road and they've been driving for 18 hours straight, as well as workers that might work in factories and they're dealing with big machinery. How much accidents can occur because of sleep deprivation? These accidents are on the rise, as well as the cost of lives each year has increased. So if you don't have any sleep going on for a period of 72 hours, have any of y'all gone through that where you've been up straight for 3 days? You might do that during midterms week, for example. Here's some things that it can lead to. Mood alterations. You might become real irritable and it'll be hard for people to approach you. Your self-esteem is going to plummet. You're not going to be able to pay attention like usual. Being able to just want to get up and do anything, your motivation is going to be lowered. There's going to be more irritability, lapses within your attention. Your reflexes is going to be out of whack. As well as when we talked about cortisol, guess what's going up? Cortisol. All right. So this slide here is just demonstrating and showing data that's been collected in sleep labs that kind of helps scientists understand the different stages of sleep. So here you're looking at when you see the signs for awake, pretty much this is low voltage, but there's a lot of beta waves going on. As you begin to get tired and drowsy, what we call alpha waves, now that's the one that's now going to start showing up more active. But then you start to feel, after drowsiness, you start to drift off to sleep. Now you're moving into what we call theta waves. And this time of sleep, it's where you're there, but at any time, if somebody make a hard noise, you probably can come right back out of it. Stage 2 is when sleep spindles are going to occur, and then we're going to really start seeing erratic behaviors in the instruments, where EEG activity starts to get mixed. It'll be light, and then it's going to jump, and then it's going to be light. You're now trying to get yourself into a deeper realm, and once you move into a slower wave sleep, which is a deeper sleep, we're now talking about stage 3 and stage 4 of sleep. And here, as you can see on the slide, now that you've got it's really going. Because believe it or not, your brain, although you're asleep, your brain continues to work. And then finally, we go into REM sleep. Okay, the REM sleep, that's more lower voltage, and here is when your dreams will be most vivid. So this information, like I said, is from a sleep lab, and participants in sleep research labs, they will wear electrodes on their heads, and as well as on their bodies, to allow the brain to be measured, as well as body to be measured for responses during these sleep cycles. The EEG, or the electroencephalograph, there it goes, will detect and record those brain waves and changes by the means of small electrodes on the scalp. Other electrodes will help to measure your muscle activity as well as your eye movements. So let's go back into talking about the stages. The stages of sleep, again, are going to be define the telltale changes within brain activity, and that represents those jagged lines that I mentioned. Your compact brain waves of alertness will gradually lengthen out as you drift into your sleep stages, which when we talk about sleep stages, there's 4 stages that's going to be within what we call non-REM sleep, the first 4 stages. And that happens before you would enter rapid eye movement, or REM, R-E-M. Okay? So, the first sleep cycle, when you go through it, it generally will last around 90 minutes. And that's going from being awake and alert to moving down in through the first 4 stages. And then it's going to go back up again through stages 3, 2, and then REM. So what happens is, when you sleep for like 8 hours, more than likely you have gone through 4 or 5 sleep cycles. Okay? The sleep, the overall amount of your REM sleep should increase as the night progresses, while the amount of your deep sleep, that stage 3 and 4, will start to decrease. So early on, when you first go into stage 3 and 4, that's going to be a longer period, but as you get deeper into sleep, the REM is going to get a little bit more time, and your 3 and 4 stages will start to decrease until the point where it's going to be where you become alert and awake again. So just as speaking more on REM and non-REM sleep, we have to look at age, because age does make a difference in the amount of sleep we do have. Aging in the sleep cycle basically is our biological need for sleep, because it changes throughout the lifespan. When you're looking at this pie chart, it kind of gives you an idea of how those sleep cycles will change from the time we're born until we enter old age. So looking at the infant, an infant, it's going to show, it's dark blue would be considered REM sleep, and then the medium blue is going to be non-REM sleep, and then awake time would be light blue. So as you can see, an infant has a lot more REM than any of the other stages. This is because infants tend to sleep between 12 to 19 hours a day, okay, on average. They're not really awake often during the day, as one would see if you had children. You understand, they wake up to eat, they wake up to be changed, and then they go back to sleep. And their circadian rhythms are off because they tend to have those awake times late at night. But just to reiterate, the average person's experiences as an infant or as an adult or as an elderly person would range particularly within those pie charts. The older we get, the less hours we get of sleep. So again, sleep happens between about approximately 40% of the time for an infant. It then decreases to 20% of the time when you become adult, where you're averaging at least between 7 to 9 hours a day rather than 14 to 19 hours a day. And then when we get into elderly age, at that point, you're now at 14% REM, and on average, it's 4 to 6 hours a night that you would get sleep. So we have to ask ourselves, why do we have to sleep in the first place? There are many different myths and misconceptions in regards to this particular topic. We'll talk more about them again when we come together on Monday and we do those myth busters. But fortunately, scientists have been carefully being able to study what sleep is and what it does for us, as well as for our dreams. And why do we spend about 25 years of our lives within altered states of consciousness? Here we're going to talk about a few different theories. The adaptation theory, for example, is where we're talking about sleep is evolutionary, and it helps to conserve energy, and also is our survival mechanism in terms of protecting us from predators. It also helps in the regard to the circadian cycles. Repair and restoration theory looks at how the body is in rejuvenation mode, so to speak, when we're sleeping. It allows us to recuperate. It allows our organisms to repair itself as well as grow during certain times of development. Speaking of growth, the growth development theory actually talks about sleep coinciding with the release of the growth hormone that comes from the pituitary gland. And we need less sleep as we get older because we're not growing as much anymore. I have a story about my son, but I'm not going to go through the whole story. Needless to say, he was short as a young teenager, and when he finally started getting the appropriate amount of sleep, he shot up like a beanstalk, and now he's over 6 feet. And if I remember, I'll tell you the whole story when we get back together. But the other theory I do want to mention is talking about our learning and our memory theory, the learning and memory theory. Here, this is talking about how sleep is really actually important for our brains to take in the information, and helps us consolidate it, helps it to store, and allows us to be able to recall things and remember. Now, here's a good tip. If I haven't said this before, and I probably have, but I'm going to repeat it anyway, because repeated actions actually helps us to learn. When you study, if you take time to study maybe 2 hours prior to going to sleep, guess what happens? Your brain continues to work, remember, as you're sleeping. And according to the learning and memory theory, during this time, that information that you fed it, it is now going to help to consolidate that and put it into storage. So if you try to study at least 2 hours, get some studying in at least 2 hours before you go to sleep and sleep on what you have learned, then you should be able to recall information a little bit better. Now, let's talk about why we dream. There are three different views. First one is talking about wish fulfillment. And here we're talking about manifest content. That's basically a surface story of a dream. The latent content is what's underneath that unconscious hidden meaning. And pretty much when we talk about wish fulfillment, that we're dreaming about things we want or need, research has not been able to provide pure scientific evidence that support that this is what's really happening. Now let's talk about the biological perspective. Here we're speaking specifically about activation synthesis hypothesis. And in this particular theory or viewpoint, it's talking about how random brain activity pretty much like your personality, your motivations, your memories, as well as your experiences, is going to be actually constructing your dream in the first place. This has had a little bit more in terms of empirical evidence to show and demonstrate that pretty much our brain is rewinding our daily events. And so that dreams that we are having is pretty much dreams of what went on during the day. Understand, our mind takes in so much data. If we looked at it as a computer, as far as information processing, we take in so much information during the day, things that you wouldn't actually realize that you took in, you did. We are, our brain filters, okay? So it's going to keep what it feels that's going to be really important, and then it lets go of things that's not as important. So your dreams can be trying to construct what went on during the day. And then sometimes there are things that happen, like when we talk about deja vu. You might feel like, wow, that just happened. I've been through this before and don't remember doing it. When in reality, you might have actually experienced it but didn't pay attention to it. And your brain is now rewinding and seeing it again. Okay, so now let's talk about cognitive. Dreams here is also going to help us in terms of processing and taking our information and updating it to the brain. And evidence is strong to show how dreams actually relate to our experiences through the day. So it kind of piggybacks off the biological, but it shows how we think about it. Like I said, our brain don't go to sleep now just because our eyes are closed and we're going through those stages. Our mind continues to work, and with the cognitive paradigm, it's saying that your mind is now trying to make sense and update its information within it so that it can lock hold and store that information. All right. So now, as always, there's descriptions of things, and what I'll ask you to do is keep this in mind. I'm not going to go through each one, but as you're doing your reading in your textbook, look at page 127 and answer these questions for yourself to keep practice, because you know they can be test questions. And look at the different research challenges that's according to this. Now finally, I'll stop here. I'm gonna go over this section, and then I'm gonna stop and we'll pick back up on Monday. But sleep disorders. A lot of people tend to deal with sleep disorders. An estimated 2/3 of American adults suffer from some type of sleep problem. And in terms of children, approximately 25% that would be under age 5 actually have sleep disturbances as well. So in our psychology field, mental health professionals, what they do is they're going to divide these sleep disorders into two major diagnostic categories, that being dysomnias, and dysomnias describes problems sleeping, and then there's parasomnias, and this describes abnormal sleep disturbances. So looking at dysomnias, you have insomnia. And insomnia is when you're having trouble being able to fall asleep, or once you are asleep, being able to stay asleep, you're waking up too early, easily disrupted. Narcolepsy, you might have seen commercials lately. They've been showing commercials. Here, this is where you have this sudden urge just to fall asleep out of the blue. You know, you might be talking to someone, and if that person's narcoleptic, they look alert to you 1 second, and then as you're talking to them, they drift off into a sleep. This generally happens to them during waking hours, and it's some of the symptoms would be a sudden sleep attack, and it could be happening while they're speaking to someone. They could be driving, they could be standing. So it's really important that they get treatment, because of course that could be detrimental to their health all around if they're driving and fall asleep. Sleep apnea is another disorder in terms of where there's difficulty with breathing while you're sleeping. Okay, usually individuals who demonstrate loud snoring or have real bad trouble staying asleep, might want to get checked to see if they have sleep apnea. Now, the next section is parasomnias, and it includes two areas, that being nightmares and then night terrors. The difference between these two, with nightmares, that's pretty much having bad dreams that's happening during their REM sleep, and pretty much it'll disrupt sleep. Whereas night terrors, this is where you waking up out of the blue feeling panic during your non-REM sleep, which is the non-REM again is during those first 4 stages. And it's going to keep you awake pretty much the rest of the night. You might wake up with palpitations, sweats, the whole 9. So I'm going to stop here. We'll talk more about it on Monday. Please make sure you complete the assignments and have a great weekend.